Dear students, today I am going to explain about fourth normal form, that is Boyce Court normal form. In the previous class we had discussed about third normal form. Third normal form is defined based on transitive dependency. Okay, now we are going to see the next normal form, Boyce Court normal form. This is stronger than third normal form, but it is weaker than the fourth normal form. Okay, so now we are going to define the BCNF. A relation schema R is in BCNF, that is Boyce Court normal form. Before that we should tell should be in a third normal form. Okay. If whenever an FD X defines A holds in R, then X is a super key of R. If suppose there is a function dependency X defines A is there, means compulsory that X should be a super key of R. Okay. So that is the condition for Boyce Court normal form. There will be multiple functional dependencies, but all the functional dependencies that X defines A, X should be a super key of R. That is the main condition for Boyce Court normal form. So each normal form is strictly stronger than the previous one. Already we have seen every second 2NF relation is in 1NF, every 3NF relation is in 2NF, every BCNF relation is in 3NF. So this like this only we can go. Every that is 4NF relation is in 3M, BCNF and so on. So here we will take, so the Boyce Court normal form, that is we will take this lots 1A with the functional dependency. FD1 will take, if we know the country name, property ID, the country name, lot number and area should be defined. But if we take FD2, if we know the area, country name is defined. That is FD5. If we know this country name and lot number, property ID is defined. So this FD2 lost that, and also if we know the area, country name is defined. Here we will take only the property ID is the super key. Other things are not super key. But in FD2, the non-super key country name and lot number defines the area and property ID. So it passes this BCNF normal form. And then another thing, area defines country name also. Area is not a super key. So this also dissatisfies that is violates the BCNF normal form condition. Okay, so not to convert that into BCNF, it is decomposed into three relations. If you first will take this property, this is not valid, so property ID defines area and lot number. So that we can take. Now we will take this property ID is a super key. It defines area and lot number. Then next we get area defines country name. So then we will make it as area as a super key and country name it defines. So this is another relation. Then next we will take that is R of A, B, C. This one, there is another example. So this two we can make it for this cannot to convert into BCNF. But not in BCNF. So this another relation we will take it. That is this one. A, B, C. That is here we will take, this is okay. This now it is decomposed into two sub-relations. It is in BCNF. But another example we will take A, B, C. Here A and B together it is a primary key, composite primary key that defines C value. Okay, A and B together it defines C value. So that is okay, that condition is satisfied. But if you will take C, C defines that is B. C is a non-super key. It defines a super key B. So it violates the condition of BCNF. So this is in third normal form, but this is not in a BCNF. Okay, so this is the thing for BCNF. So here relation teach that is in 3NF but not in BCNF. This is also another example you can take, student, course and instructor. This example also we can take. So here that FD1 is student and course we know, the instructor we can find out. If instructor we know, course we can find out. Here we will take instructor is not a non-super key, but that defines the super key, course part of the super key, course primary attribute. So this is relation is in 3NF not in a BCNF. Okay, so this is the condition you should know. So BCNF means there should be a relation like X defines A, in that X should be a super key. Okay, that should be the main condition. So the relation not in BCNF should be decomposed so as to meet this property. The above property it has to meet X defines A, X should be a super key, while possibly foregoing the preservation of all function dependencies in the decomposed relations. Okay, so this is the main thing in the BCNF, Boy's code normal form. So the Boy's code normal form is stronger than third normal form and weaker than this fourth normal form. Okay. So BCNF, first the relation is in BCNF, means first it should be in 3NF, and also it has to satisfy the condition like X defines A, X should be a super key of R. Okay, so that's in that thing. And then in this BCNF, when you are seeing we have to see the test for checking non-additivity of binary relational decompositions, that is testing binary decomposition for lossless join. So lossless join is important. When we have seen, when once we are decomposing the relations, we are going to join the relations again using natural join operation. It should be a lossless join. So here we are having binary decomposition. So decomposition of a relation R into two relations. We are making decomposing into two relations. Binary decomposition, decomposing into two relations. So non-additive joint test for binary decomposition means a decomposition D equal to R1 R2 of R, capital R, has the lossless joint property with respect to a set of functional dependencies F on R if and only if there is a function dependency R1 intersection R2 defines R1 minus R2 is in F plus function closure of F, and R1 intersection R2 defines R2 minus R1 is in F plus. So either in the case we can take R1 intersection R2 defines either R1 minus R2 in F plus, or R1 intersection R2 defines R2 minus R1 in F plus. So these things is called as a non-additive joint test for binary decomposition. So binary decomposition means you should remember decomposing of a relation R into two relations, that is binary decomposition. Okay, so that's all about BCNF. So BCNF means Boy's code normal form. It is stronger than third normal form, and each the function dependency should be X defines A, X should be a super key of R. That's all.